Welcome back. And so we're going to be solving more triangles. We're going to be solving for any missing angles and missing sides. In the last video we had a lot of examples where we knew two angles, the right angle and one other angle, and so we could use triangle sum theorem. In this video we're going to focus on inverse trig ratios. And we're going to actually solve both angles using inverse trig ratios just for a little practice. We'll also use Pythagorean theorem to find the missing side, which will give us some good practice with being able to simplify radicals. So as a reminder, to use inverse trig ratios to solve for missing angles, you identify the sides. In other words, relative to an angle you want to find. Do you know the opposite, the adjacent, the hypotenuse? You pick which trig ratio matches what you know. You substitute the values, you isolate theta, and you evaluate the inverse. And that we can either use the trig table for or the calculator. I'm going to focus on the calculator in this series of lessons. All right, so now let us find our missing side. We are missing the side opposite from angle A, so that would be side A. And because we know two sides in a triangle, let's use Pythagorean theorem. Right, so I'm going to kind of squeeze it over here. Hopefully I can fit everything in on this page. All right, so the A is a leg, so 10 is the hypotenuse, so that gets isolated. 10 squared equals A squared plus 5 squared. 10 squared is 100. 5 squared is 25. Let's subtract 25 from both sides, so we have 75 equals A squared. And then we're going to take a square root of both sides. Now we can simplify the square root of 75, right? And we know it's not a prime number, right? So it's divisible, certainly divisible by 5. So we may as well see if we can also simplify that radical. Right? So 75, I said it's divisible by 5, right? So I can divide by 5. If I divide 75 by 5, that would go in 15 times. 15 is divisible by 5. That's 5 times 3. And notice we have a pair of 5s. 1 5 comes out, 1 5 goes away. The 3 did not have a buddy, so that's going to stay in the radical. So A here is equal to 5 square roots of 3. Now that is an exact answer, and we could technically use it to calculate our trig ratio, but I think 5 and 10 might be some nicer numbers to work with than 5 square roots of 3. And so those are the ones we should use. Now let's identify, we'll solve for angle A first. All right, so relative to angle A, the side marked 5 centimeters is the adjacent side. The side marked 10 centimeters is the hypotenuse. So who uses adjacent and hypotenuse? Well, of course, that's cosine. So now we're going to write, and so we're solving for A, that's our unknown. All right, so when we write our equation, we start with the trig ratio always, cosine, then the angle. All right, so let's just call it cosine A, because we have two angles to solve for. Cosine A equals, and then cosine is adjacent over hypotenuse, so that's 5 divided by 10. When you're writing ratios, you do need to simplify, and you need to reduce if possible. When you're solving for angles, it doesn't really matter if you reduce or not. All right? So that would be cosine A equals 1/2. That's probably what I'll plug into the calculator, just because maybe it's a little easier for me. All right, so now we want to isolate A, so we take an arc cos of both sides. And I'll put a 1/2. I'll just simplify that. We know that that's an easy reducing. Arc cos and cos are inverses. They cancel each other out. That's what an inverse is. None does. All right, and we're left with A on the one side. On the other side, where you have arc cos of 1/2. And now we're going to plug that into the calculator and find out exactly how big angle A is. All right, so we have 1/2, or I could just put 0.5, right? Everyone agrees that 0.5 is 1/2. And then now we want our cos, so we got to hit shift, and that is 60 degrees. And actually, before I even plugged it in, I knew this was going to be a 60-degree angle because this is a special triangle. And I knew it was a special triangle based on the values of the leg and the hypotenuse, that it had to have an angle of 60 degrees. You'll learn why next year in Algebra 2. Let's solve for the other angle. Now, we could easily use triangle sum theorem to find it, but let's just get a little practice in and use a trig ratio on this one as well. All right, so we're just going to use trig ratios on both of these, both angles in both of these problems. So I guess I'll solve up here. All right, so let's identify what trig ratio we have. So we're looking here from angle B's perspective. From angle B's perspective, that is not the adjacent anymore. That is the opposite. Right? So who uses opposite and hypotenuse? Of course, that's sine. So sine B equals 5 divided by 10. Right? That's also 1/2. Let's take the, okay, I have cosine in my head. Let's take the arc sine of both sides. Oh, and actually I'm just going to write 1/2. Sine and arc sine cancel, so that is B equals arc sine of 1/2. That's all there is to it. And now let's plug that into a calculator. Now we're expecting 90 plus 60, right? That leaves 30 degrees, right, left for angle B. So we're expecting to get 30 degrees. Let's see if that's what we get in the calculator. All right, so 1/2 is the same as 0.5. So let's clear that. 0.5, and then arc sine. Look at that, 30 degrees. Now, we didn't have to use a trig ratio here to solve for angle B, right? We could have just plugged that into, we could have just used triangle sum theorem, right? And that would have been totally fine. So I'm going to just note what we did here. We found the side, that missing side, and there we used Pythagorean theorem. And then we found angle A. And then finally, we found angle C, or angle B, excuse me. All right, let's do the same thing with the other triangle. All right, we'll find the missing side, and we'll find both angles. And we'll practice using a trig ratio with that. Here we are missing side D, and side D is a hypotenuse. So D squared equals 4 squared plus 6 squared. Right? Pythagorean theorem, the hypotenuse squared equals the sum of the legs squared. So 4 squared is 16, 6 squared is 36. Right? So that's going to be 52. And this will simplify. If you just think about the factors of 52, you'll realize, oh yeah, it's got a factor that's a perfect square. So if I divide by 2, right, I could divide by 2 if I want, I get 26. Or I could divide by 4 and get 13. 26 is 2 times 13. 2 is prime, and so is 2 is prime, and so is 13. But notice we have a pair of 2's, which means 1 2 comes out, 1 2 goes away. So D here is equal to 2 square roots of 13. So the first thing we did was we found our missing side using Pythagorean theorem. Now let's find our missing angles using inverse trig ratios. All right, so number 2, it doesn't matter which side we find first. I guess we'll find E. We'll go alphabetical. All right, so find angle E. All right, so notice that 6 and 4 are both legs. 6 is the opposite side, it's across the triangle, and 4 is the adjacent side. Who uses opposite and adjacent? Of course, that's tangent. So we have tangent E equals 6 divided by 4. We could reduce it or not. It's an easy reducing, so I think I just will. We take the arctan of both sides to isolate E. And I'm just going to write that as 3/2. I may as well. Arctan and tangent cancel, so that's E equals arctan of 3/2, and then we'll just plug that into the calculator. Now this one I don't think is a pretty angle like 30 and 60. All right, so we have 3 divided by 2. I also could have put in 1.5. And then we're going to hit arctan. So that is 50, and we'll round to the nearest, we'll round to 2 decimal places, I guess, 56.31 degrees. Now we could subtract that from 180, or we can use a inverse trig ratio again. I'm just going to use an inverse trig ratio just for the practice. I'm going to move this over a little bit. And then I can solve in that little corner there. Whoops, my 2 problems are kind of running into one another. There we go. All right, so over here, let's find angle F. All right, so we still have the 2 legs. The only thing that's changed is now, from F's perspective, opposite and adjacent have switched. So now 4 is the opposite and 6 is the adjacent. So we have an opposite and adjacent is still tangent. So tangent F equals the opposite side, which is 4, over the adjacent side, which is 6. We'll take an arctan of both sides. Oops. And let's see if I have enough space. I need like just a tad, just an itty bitty bit more space. Equals arctan, and I'll abbreviate that to, reduce that to 2/3. Okay, I think I'll have enough space. Arctan and tangent cancel. That's F equals arctan of 2/3. And let's plug that into a calculator and find out exactly how big angle F is. So we have 2 divided by 3, and we want arctan. Oops, maybe I hit equals. Otherwise, it'll think it's 3. 33.69. And if you notice, if you add 90 plus 56.31 plus 33.69, it does add up to 180. And that's why we can just use triangle sum theorem. And I will on the next examples. All right, so I'm going to pause. I'm going to end this video. In the next video, we're going to solve another problem. Right, and so this one, we won't be using inverse trig ratios, but we will be using trig ratios to solve for the missing sides and angles in our triangle. Thanks for watching, and bye for now.